Hey everybody, it's Mr. Goodale. I hope you're doing well. I'm doing well. We are coming down to the end of things here. It's almost spring break. I believe I assigned this on the Monday of the week before spring break, and I'm going to assign it for both remote days this week. That means that the A-Day kids are going to do this on Friday, and I don't expect 100% compliance. Let me put it that way. And it's not the kids' fault. Often families go places or kids are checked out or whatever it may be. So I'm going to assign this assignment for the 2 days, asynchronous days of this week. Either that's Monday, Thursday, or Tuesday, Friday. If you get it done, you get it done. And there's nothing for you to do in addition to this on the asynchronous day. It's a chance for you to finally show me what you know about trophic level diagrams and all these food web interactions. Sorry. I'm showing you this picture because this week, my bad, this week we are going to go outside and we are going to collect things to put in what we call an eco column. And an eco column is a self-contained ecosystem. And the whole goal of it, and in killing essentially the things that are in there, because they're not going to live in there for a while, for very well for that long, is to learn these fundamental principles of the carbon cycle, of recycling of matter, and the flow of energy going into ecosystems. So those are the main three components. I'm showing you this because I just want you to be prepared. Be prepared to go outside, dig around. You can see there, Calvin this is Chance's brother, he has like a trowel, and you're going to be digging up earthworms and soil and things like that, some plants. So anyway, just be prepared to go outside no matter what the weather is. The goal then is to build these so that they can then sit all spring break. And then when we come back, we'll start getting some data from them. Well, here's the state standard that we're going to be acknowledging over this week, essentially for both this current assignment as well as the eco column. I'm going to read this to you because this is basically the carbon cycle, and you're going to see this on your exam. It says discuss the interdependence of autotrophic and heterotrophic life forms. Now, what's an autotroph? It means self-food, or something that's going to make its own food, like a plant, using photosynthesis. And then heterotrophs are things that need to consume other things in order to get their energy, like humans or a bunny rabbit. And so there's an interdependence there of autotrophs and heterotrophs. And we're going to do this by depicting the flow of a carbon atom. So we're going to basically, or you're going to need to be able to do this at the end, is follow a carbon atom through this whole cycle between essentially plants and animals. We'll just simplify it there. It says here, from the atmosphere to a leaf, through the food chain, and back to the atmosphere. This is state standard. I didn't want to do that. State standard 2.4b. So please just be able to follow the cycle of a carbon through biology, through these systems. Well, I'd like you to get out a piece of paper, and I want you to draw what's on the board, which I'm going to put here on the screen. And where the carbon cycle always starts out is in the atmosphere. You can see carbon there. It's stuck into a molecule. Excuse me. It was just a time change. Sorry. Stuck into a molecule that we call carbon dioxide. You can see it there. And it's going to be incorporated into biological systems through photosynthesis. Sun is a player here. There needs to be a constant flow of energy, as well as water, which plants, for instance, take up from the soil and bring up to the photosynthetic cells that exist in the leaves. So please make sure you write this down. It's going to be a circle here. What happens then at the end of photosynthesis, that carbon atom that you see way up there in that carbon dioxide molecule is now in a different molecule, and that molecule is called glucose. Glucose then is the fuel, it's the primary fuel for all the biological systems. Either something eats plants or it eats something that ate plants. Let's say if it's a dinosaur or a shark or something, it's going to eat, it's at the height of the food pyramid, and it's going to eat things that eat things that eat things that eat plants. But the whole point is that it all comes down to plants. And there are photosynthetic bacteria and other things that do photosynthesis. But primarily, the carbon in the carbon dioxide in the atmosphere is incorporated into glucose through photosynthesis in plants. Then organisms such as people, and I've drawn a little stick figure man there, and I'd like you to trace this whole circle around. Um, you can see then that through cellular respiration, we're going to take in that carbon dioxide, break it into its component parts, which are water, ATP, which is I guess, energy that's going to fuel the production of ATP, which is an energy storage molecule that humans and other higher organisms use to store energy temporarily until we're able to harness it to do things like pump our heart, focus our eyes, allow us to walk down the hallway, anything like that. And then carbon dioxide is a byproduct of this process. And you can see it there. You see the arrows up top, how it then goes back out in the atmosphere, and it's a cycle. It's called the carbon cycle. So what I'd like you to do is finish this drawing, close your eyes, and then recite the carbon cycle. If you need help, look back at the drawing. If you need to do it again, meaning explain it again, do it again. Do it till you get it, please. Well, I've drawn up here a picture of carbon dioxide layer of gas in the troposphere, which is above the Earth. And you can see the sun's rays are going through this layer of gas, and then it's hitting the Earth and coming back, and then it's being reflected back down to the Earth. This is called a greenhouse effect. Essentially, it's the same thing that happens in Frankel's greenhouse here. And then heat can be trapped, and this is what's happening currently on our planet, is that our surface temperatures are rising over these years because more and more CO2 is a part of that layer that's going to trap the sun's energy. It's irrefutable. It's happening. The data suggests it. What's a question is are humans causing it? I think so, but it's open to debate. And then number two, what's going to happen because of it? So you can't get away from the carbon cycle or talking about it without seeing stuff on global warming. I'm just bringing that to your attention. Well, here it brings us to our assignment. Basically, I'd like you to create a poster. Now, you can go all out here and create a big poster on a piece of poster board or something like that in class. I would have given you paper to do this, but at home you can just do it on a simple 8.5 by 11 piece of paper. You also don't have to use color, but I would like you to use color. But I'm not gonna. If you don't have colors in your house, I'm not going to force you to use colors. But it's just better when there's color. It's just easier for me to see your thinking. It says here, on a poster, draw a marine or coral reef or ocean ecosystem and a desert ecosystem. Identify the producers, consumers, and how energy flows and matter is cycled in these ecosystems. This is important because it's a chance for you to show me what you know. Make sure that you answer those 3 questions somewhere on the poster, and let's do this. You only have to do one of either of those. You can either choose some sort of ocean ecosystem or a desert ecosystem. I'm going to show you one more slide of things that I'd like you to incorporate into your poster. Make sure that you identify all these things on your poster. And again, this will be a real crowded piece of paper, but I'm okay with that. Primary, secondary, tertiary consumers. Make sure to identify these individuals on your poster. Apply the 10% rule. Show how energy flows, matter recycles. Talk about biomass, and make sure that you have one of these trophic level pyramids. So there's a lot going on here. You can even flip over the paper and do some of this stuff on the back. This is your only assignment for the next 2 nights, this night as well as your next asynchronous night. Thanks, and I'm excited to build eco columns with you. We, of course, didn't get to do it last year because of the pandemic beginning. So I think it's a lot of fun for kids to finally apply the science and use their hands to build something of their own creation. I'm going to show you a movie here. So this movie is also on the Schoology page down below. It's probably best watched just from the original that I got off of YouTube and I put there. So I'm going to stop this now. Thanks. Good luck on your poster, everybody.